ਹੈਲੋ ਪਲੱਸ 2 ਮੈਡੀਕਲ ਨਾਨ ਮੈਡੀਕਲ ਦੇ ਪਿਆਰੇ ਪਿਆਰੇ ਵਿਦਿਆਰਥੀਓ ਅਤੇ ਬਹੁਤ ਹੀ ਸਤਿਕਾਰਯੋਗ ਅਧਿਆਪਕ ਸਾਥੀਓ, ਅੱਜ ਦਾ ਟੌਪਿਕ ਮੈਂ ਸੈਕੰਡ ਯੂਨਿਟ ਆਫ ਫਿਜ਼ਿਕਸ ਫਾਰ ਪਲੱਸ 2 ਕਲਾਸ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ ਸ਼ੁਰੂ ਕਰਨ ਲੱਗਿਆ। ਅੱਜ ਮੈਂ ਡਿਸਕਸ ਕਰੂੰਗਾ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ ਐਂਡ ਡ੍ਰਿਫਟ ਵੈਲੋਸਿਟੀ ਬਾਰੇ, various relations of electric current and drift velocity and electric field। ਸੋ ਧਿਆਨ ਨਾਲ ਸਮਝੋ, ਬਹੁਤ ਹੀ ਸੌਖਾ ਔਰ ਇੰਪੋਰਟੈਂਟ ਚੈਪਟਰ ਹੈ। ਸੋ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ ਕੀ ਹੁੰਦੀ ਹੈ? ਵਾਟ ਇਜ਼ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ? ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ is defined as the rate of flow of charge, that is charge flowing per second is known as electric current or current electricity. So I is given by Q upon T. Q is equal to N into E. N is the number of electrons, E is the charge upon each electron. So total charge that flows, suppose Ne upon T. If current is variable, then it is defined as I is equal to dq upon dt. That is, electric current may also be defined as the first derivative of charge with respect to time. Units of current, charge in coulomb, time in second. So coulomb per second or 1 ampere. So ampere is the unit of current in SI system. So current flowing through a conductor is said to be 1 ampere if a charge of 1 coulomb flows in 1 second. Then we define drift velocity. So suppose we have any conductor, and in a conductor there are large number of free electrons which move in random fashion with very high velocities. So when there is no potential difference, when conductor is as such, no potential difference is applied across the wire or the conductor, then these electrons, they follow the zigzag path, random fashion, random motion. So there is no net flow of charge in a particular direction. Even electrons are moving with very high velocities of the order of 10 raised to 5 meter per second. But there is no net flow in a particular direction, so there is no current, because current is nothing but rate of flow of charge in a particular direction. So when there is no potential difference, there is no electric current. Clear? Now, suppose we have a conductor of length L and potential difference V is applied across the ends of the conductor with the help of a battery. One end becomes positive, other end becomes negative. So PQ is the conductor of length L. Then what happens? Then each and every free electron starts drifting toward the positive end. Starts drifting toward the positive end. Then the average velocity of each free electron with which it drifts toward the positive end of the conductor under the influence of electric field or potential difference. So because the potential difference is applied, each and every free electron experiences an electrostatic force, which is given by F is equal to minus EE. As a result, it gets accelerated, it gains speed, it gains velocity, but it has to collide with the atoms or molecules of the conductor. At every collision, its velocity and hence kinetic energy is lost in the form of heat. So as a result, free electron starts drifting toward the positive end under the influence of electric field, but their average velocity is very, very small. That average velocity is called drift velocity, and it is of the order of 10 raised to minus 4 meter per second. So drift velocity, the average velocity with which each and every free electron is drifted toward the positive end under the influence of electric field is called drift velocity, and it is very small, of the order of 10 raised to minus 4 meter per second. Now, if we have to reduce relation between drift velocity and electric current, suppose L is the length of the conductor, A the area of cross section of the conductor, N is the number of free electrons per unit volume of the conductor. Then time taken by the electron to cover this length L of the conductor is given by T is equal to L upon Vd, where Vd is the drift velocity, time, distance upon speed. Say equation number 1. Then volume of the conductor, area of cross section into length is equal to A into L. If N is equal to number of free electrons per unit volume, then total charge that flows is given by N number of free electrons per unit volume into Al, that is total number of free electrons within the conductor of length L, into charge upon the each electron. So this is the total charge that flows. Q is equal to NEAL. So divide second equation by first. So we have Q upon T because we have to find current. So I is equal to Q upon T, that is NEAL upon L. L cancels, or I is equal to NEAVD. I is equal to NEAVD. So which is required expression for electric current and drift velocity, where N is the number of free electrons per unit volume, which is given, E charge upon each electron 1.6 into 10 raised minus 19 coulomb, A area of cross section of the conductor or wire, Vd is the drift velocity of the electrons. Then if you have to find current density, so current flowing per unit area of the conductor is given by, is known as current density. So J is equal to I upon A. So from this equation, I upon A becomes NEVD. So this gives the expression for current density and drift velocity. And units of current density will be current upon area, that is ampere per meter square. Then we have to find a relation between drift velocity and electric field, because this is the relation between drift velocity and electric current, or drift velocity and current density. Now we have to find a relation between drift velocity and electric field setup, because when there is a potential difference, electric field is set up from positive to negative end, and electron moved in a direction opposite to the electric field, because they experience force in the opposite direction, being negatively charged particles. So the direction is the electron flow, it is known as electronic current, and a direction opposite the flow of electrons is known as conventional current, I. In current is a scalar quantity, it is not a vector quantity, but it has specific direction, which is taken from negative to positive through the battery, or positive negative outside the battery, in the outside circuit. So this gives direction of conventional current, which is opposite to the flow of free electrons. Then we have said that under the influence of electric field, each and every free electron experiences the force, which is given by F is equal to minus EE. It means each electron gets accelerated. So A is given by, A is equal to minus EE by M, the vector form. Because of this acceleration, again I repeat, each and every free electron acquires velocity, acquires kinetic energy, gains kinetic energy, but a part of its kinetic energy lost at every collision. So because they had to suffer inelastic collisions with the atoms or molecules of the conductor, that's why their velocity is reduced, and kinetic energy appears in the form of heat, wire or conductor becomes hot. Let U1, vector U2 and so on Un be the initial velocities of the electrons, initial velocities T1, T2, Tn, time intervals for respective electrons between two successive collisions, or time during which electron particular electron relaxes. Then their final velocities V1, V2 and so on Vn, corresponding final velocities will be given by using V is equal to U plus AT. So V1 for first electron, U1 plus AT1, V2 second electron, V2 plus is equal to U2 plus AT2 and so on. Vn will be equal to Un plus Atn. So V1, V2, Vn with the final velocities of the respective n electrons. And we have to find drift velocity. So drift velocity is the average of all these velocities. So Vd is equal to drift velocity. So Vd will equal to V1 plus V2 plus so on plus Vn upon n. Or if you substitute the values of V1, V2 and simplify U1, U2, Un, we can put within this bracket. So Vd is equal to U1 vector plus U2 vector plus so on plus Un upon n. Plus the second term A is common. So A common, A vector common, T1 plus T2 plus so on, Tn upon n. Now, this U1 plus U2 plus Un upon n is equal to 0 because initial average thermal velocity is 0. Initially, when time potential difference was 0, electrons were in random fashion. So U1, U2 plus U2, this sum will be 0. Or you can say average thermal velocity is 0. So therefore, we have T1 plus T2 plus so on plus Tn upon n is equal to tau. Tau is called relaxation time. The time during which electron relaxes. Or you can say relaxation time is an average time between two successive collisions of the electrons. So Vd is equal to, from this equation, A into tau. Vd vector is equal to A vector into tau. And from equation number 1, vector A is equal to, that is acceleration minus E by m upon tau. So which is required expression between drift velocity and electric field. And it is very clear this negative sign indicates that drift velocity has direction opposite to the that of electric field. Drift velocity of electrons is opposite to the applied electric field, where m is the mass of electron. Then we define mobility. Mobility mu is defined as the ratio of drift velocity to the electric field. Drift velocity to the electric field. From this question, we can find Vd upon A is equal to E tau by m magnitude. So for electrons, because this is E the charge upon each electron, and in general, you can take mu is equal to Q tau upon m. Q charge upon the particle, moving particle. So units of mu will be Vd drift velocity meter per second. Electric field will be volt per meter, or you can take Newton per coulomb. To simplify it, it will be meter square, volt inverse, second inverse. If we put units of E as Newton per coulomb, it will be meter per second per Newton coulomb, because E is equal to F upon Q. So this is all about electric current, units of electric current, drift velocity, relation between drift velocity and electric current, relation between drift velocity and electric field, as well as the definition of mobility of charged particles. So this is all about today's topic. So ਚੰਗੀ ਤਰ੍ਹਾਂ ਇਹਨੂੰ ਦੁਬਾਰਾ ਫੇਰ ਤੁਸੀਂ ਦੇਖ ਕੇ ਸਟੱਡੀ ਕਰ ਸਕਦੇ ਹੋ। ਫਿਜ਼ਿਕਸ ਬੇਟਾ ਬਹੁਤ ਸਿੰਪਲ ਹੈ, ਲੇਕਿਨ ਜੇ ਤੁਸੀਂ ਪਿਆਰ ਨਾਲ ਔਰ ਕੋਈ 7-8 ਘੰਟੇ ਰੋਜ਼ ਪੜ੍ਹਨ ਦੀ ਲੋੜ ਨਹੀਂ, ਤੁਸੀਂ 1 ਘੰਟਾ ਫਿਜ਼ਿਕਸ ਵਾਸਤੇ ਰੱਖ ਲਓ, ਬਾਕੀ 1 ਘੰਟਾ ਬਾਕੀ ਸਬਜੈਕਟ ਵਾਸਤੇ, ਪਰ ਕੰਸੈਂਟਰੇਸ਼ਨ ਨਾਲ ਪੜੋ। ਚੰਗੀ ਤਰ੍ਹਾਂ ਪੜੋਗੇ ਤਾਂ ਫਿਜ਼ਿਕਸ ਤੁਹਾਨੂੰ ਬਹੁਤ ਸੌਖੀ ਲੱਗੂ। ਬਾਕੀ ਨੈਕਸਟ ਵੀਡੀਓ 'ਚ we'll discuss Ohm's law and resistance. So till then, stay tuned, be happy, all the best.